Today, we're going to dive deep into a single research paper from 2017. The title sounds pretty simple, right? Attention is all you need. But what's inside didn't just nudge the field of AI forward. No, it pretty much created the entire world of AI that we're all living in right now. This is that story.
But let me ask you a question first. Have you ever been using something like ChatGPT or Claude and just stopped and wondered, how does it get it? How does it actually understand the nuance and the context of what you're saying? Well, it's not magic. It's a very specific piece of engineering, and the blueprint for it was laid out right in this paper.
All right, so here's the plan. First, we're going to look at the big problem that was holding AI back, which I'm calling the sequential bottleneck. Then, we'll get into the wild idea that completely shattered it. We'll take a peek under the hood of the machine they built, the transformer, see the mind-blowing results it got, and then we'll connect all those dots to the AI explosion that's happening as we speak. So, let's get into it.
So before 2017, AI language models basically had a speed limit. They were totally stuck thinking in this one foot in front of the other way, and it created this huge traffic jam for any real progress.
Back then, the big players were these things called recurrent neural networks, or RNNs. And honestly, you can think of them as reading a sentence pretty much the same way you and I do. One word at a time, from left to right. Now, that sounds super logical, but that step-by-step process, it created two massive problems that were holding the entire field back.
And yeah, this slide just lays it all out, right? On the left, you've got the old way. Because it's processing word by word, you can't really speed it up with modern computers. It's just slow. But even worse, by the time the model got to the end of a long sentence, it would literally forget what it read at the beginning. That's what's called the long-range dependency problem. And it's the reason early AI couldn't hold a decent conversation. I mean, how are you supposed to answer a question if you've already forgotten the first part of it? The new idea, the one that became the transformer, was to do something that sounded kind of crazy. Just process every single word at the exact same time.
So to fix this, the research team over at Google, they didn't just suggest a small tweak. No, they proposed tearing the whole thing down and building a brand new foundation for AI language. It was a complete break from everything that came before.
This sentence right here from the paper's abstract, this was a bombshell. The keywords are based solely on attention mechanisms. They were literally throwing out the entire engine of the old models, all that recurrent stuff, and replacing it with just one single powerful idea.
And this is the magic trick. It's called self-attention. So instead of plodding along in a straight line, one word at a time, self-attention lets every single word in a sentence look at every other word, all at the same instant. It's like it creates this huge, complex web of connections, where each word is constantly asking, how relevant are all you other words to me? It's a totally different way of understanding context.
So how does this actually work under the hood? Well, the paper uses these three ideas: a query, keys, and values. The best way to think about it is like you're at a library. Let's say we had the sentence, "The cat sat on the mat," and "it was fluffy." We need to figure out what it means. So, it becomes our query. That's our research topic. The model then takes that query and compares it to all the other words in the sentence. Those are the keys, like the titles of all the books in the library. It quickly finds a match. The key cat has a really high relevance score. So, it grabs the meaning of cat, which is the value or the actual content of the book, and understands, aha, it means the cat. And here's the crazy part. It does this for every single word all at once.
But the genius of this paper didn't even stop there. The researchers realized that, having one attention mechanism looking at a sentence is great, but what if you had a whole bunch of them, all looking at the sentence from different angles?
So, that's what they did. They didn't just use one. The original transformer used 8 of them, all running at the same time, in parallel.
This is what's called multi-headed attention. And you can think of it like having a committee of 8 different experts all reading the same sentence. Maybe one expert is just focused on grammar. Another is an expert at figuring out what pronouns, like it or they, refer to. A third might be looking at the relationship between actions and objects. By combining the viewpoints from all 8 of these heads, the model gets a way richer, more nuanced understanding of the text.
Okay, so we've got this beautiful, new, super fast architecture. It all sounds great on paper, but you gotta ask, did it actually work? Well, let me tell you, the results weren't just good. They were absolutely revolutionary.
Let's just look at the hard data from the paper. On a standard translation test, the big transformer model hit a score of 28.4. Now that number is a metric called a blue score. Higher is better. But here's the thing. It wasn't just a little better than the old models. It was over 2 full points higher. In this field, a jump that big is, well, it was basically unheard of. And then look at the training cost. It got this incredible result using way, way less computer power.
This chart really just says it all. This wasn't some tiny, incremental step forward. This was a giant leap. They completely redefined what state-of-the-art even meant. The transformer wasn't just more accurate, it was way more efficient.
Think about this. The big model was fully trained in just 3.5 days on only 8 GPUs. That efficiency, that is the absolute key. Because the attention idea could be run in parallel so well, it suddenly opened the door to training much, much bigger models on way more data, something that was just impossible with those old, slow, sequential models.
And that efficiency, that scalability, that's what brings us right here, to today. This paper wasn't just the end of an old way of doing things. It was the spark that lit the fuse on the AI era we are all living through right now.
This is its legacy. The transformer architecture became the blueprint for almost every major language model you've ever heard of. BERT from Google, yep, and GPT from OpenAI, the T literally stands for transformer. Its parallel design is what let these models grow to have hundreds of billions of parameters. It finally solved that annoying long-range memory problem, which is why AIs today can actually follow a long conversation or summarize a huge document. It completely changed the game for the entire field. So in the end, by letting a model pay attention to everything at once, the transformer blew apart the sequential bottleneck that held AI back for so long. It was the one single innovation that truly enabled this revolution. And that just leaves us with one last big question to think about. Attention was the answer back in 2017. What's the great bottleneck that needs solving today?